Hi. So I thought I'd make another little video today on defluxing. So I just put some kits together and you can see that this board has some flux buildup on it, which shouldn't really hurt anything, but it looks bad and it actually does cause problems sometimes, especially with digital signals, things, anything that goes really fast. This is the not quite the latest kit, but white board from Boldport. It's just a little power supply to plug onto a breadboard. I've actually got two of them, and you can see they both came out about the same. So for those of you who aren't familiar, the flux is this kind of amber, brownish, orangish colored buildup that you see around this various solder points. Depending on the solder you use, sometimes it's clearer, sometimes it's browner, just depends. Also, if you burn it, if your soldering iron's too hot, it'll be darker. So we want to get that off of there. I also built another Monarch. This board, since it's red and black, it's a little harder to see, but if I get the light to reflect on it just right, you can still see there's some buildup around there. That's the top side, and then on the bottom side there's some around the pseudo surface mount components and the LEDs and resistors and whatnot. So we'll clean that off. And then I've also got another binary clock that I built. There's some residue on this, so you can see a little around the serial port pins there. And then also on the back side around the power connector and all the points for the LEDs. So we'll clean that, and then I've also got another spool that I built. There's a little bit inside here. It's harder to see because of the angles, but we'll clean that up too. So I thought I'd show you what my process is for removing this just nasty buildup and making your builds after you've completed them look really pristine and nice. Especially with these white circuit boards, it really stands out. It looks really bad. Lighter colors in general. So anyway, so what I've got is a disposable plastic bin, reusable. These microwavable things has probably at some point had some noodles in it or something, I don't know. But the point is, I'm not going to use this for food anymore, and if you do this, you shouldn't either. And the process I have is honestly pretty simple. You take the board, put it in here. And you do have to think about the parts that are on here too before you do this. This has a beeper on it. I've covered the little orifice, the opening in the beeper, with some Captain tape to keep liquid from getting in there. The underside is epoxy filled, so it won't get any liquid in there anyway. The rest of the parts are, let's be honest, they're plastic and metal, or epoxy and metal. So, how do we clean it? We put the board in the bin. I have some 91% IPA. I got this, I think, from Target. It's a nice jug of it. It was about $3. We take it and just pour it on. I'm gonna fill this pretty full. These LEDs stick up, and I don't really care about wasting this stuff because it's pretty cheap. But the alcohol will just dispose, or just dissolve, the flux. The other thing I have, great tool, highly recommended. This is this plastic ESD brush. It looks like an oversized toothbrush. I got this from Adafruit. It was also about $3. Highly recommended. And we're just gonna take this and scrub the board. Particularly the areas where there's flux buildup that I want to get off of here. So you won't see it as clearly on this purple board from Oshpart, but you'll see it on the white ones. Figured I'd do this one first since it's the biggest. So I just kind of, it's hard doing this in the air too. It's a little easier on the counter. You set this down, and I just kind of use the brush to push the alcohol around and over the areas you want to clean. And if you look closely, I'm actually going to put some more in here. If you look closely, I'm not sure if you'll see it on the video, you can actually see this stuff dissolving. It turns kind of whitish. It turns kind of whitish as it dissolves, and then the brush pushes it away. It gets really soft as it dissolves. There's also some flux that's designed to dissolve with just water. So you need to look at the solder that you have to kind of take a look at what you might have. But you can probably kind of see, although it's still got a lot of liquid on it, that the flux is mostly gone at this point. It's mostly dissolved. Let's flip this over, hit the top side a little bit. Around these pins down here. Usually where I get a little build up. I put the connectors on these things on the bottom side of the board. I think it looks a little nicer. And just kind of do around the processor and some of these other chips down here in case there's any. I probably did at least a little bit of touch up on here. So that should do it for this board. Let's take it out of the bin. Take a quick look, kind of shake it off. So you can see the flux is pretty well gone at this point. So the last step, yes, I'm running my circuits under the kitchen sink. Why? The alcohol dissolves the flux. If you let the alcohol evaporate as it normally would, it's just going to redeposit the flux on your board elsewhere. You need to get it off. There's two ways you can do that. With canned air, which I'll show you in a second, or by just rinsing it. And a lot of people are afraid to put their electronics under water. And there's a good reason for that, especially if it's something like a laptop or computer or a cell phone. The thing is, water reacts with metal, especially when you leave it for a while. That's where this canned air comes in. What I'm going to do with the canned air is blast out as best I can underneath every one of these ICs on here, as well as the connectors. You don't want to leave the water on the board because it will destroy your components and your board if you leave it there. If you get it off as soon as you put it on, it's not going to cause a problem for you. That said, there are some components that are sensitive to liquids, things like speakers, microphones, buzzers, certain types of capacitors, possibly switches, variable resistors. But again, a lot of these things, if you get the water off as soon as you put it on, it's going to be okay. So here we go. That flux is gone. Totally dissolved. This board looks really nice. I've got a little lint from the paper towel. My solder joints are not perfectly smooth, but that's easy to bump off. But the next question you ask is, you got it all wet, I bet it doesn't work anymore. Normally let them dry a little longer before you do this, but they most certainly work. You definitely need to dry them off. I actually have a couple of cans of air, so I kind of alternate between. So there we go. It still works. The touch keys respond. It behaves exactly as I expect. You just do need to make sure that you get it dry before you start applying power to it. The red LED you saw just a second ago was actually an error code indicating the oscillator didn't start, the external oscillator, probably because it was still wet. So I blasted a little more with some air, and life is good. You're not going to damage anything. It wants me to set the clock since it's a clock, but in any event. So you can see this is not going to break your stuff. life will be good afterwards. Let's do a couple more boards here. We've got these white boards. Oop, a brush fell in. So let's do these. These again, really nasty looking. You can see all of that. So I'll switch this around for a minute. Maybe add a little more fresh stuff since I took some out. And then if I hit this with the brush, you might actually be able to see it dissolving off of here. Yeah, you can see it's dissolving. I'll give it a little bit more time here. Oop. Try not to bump the camera. These are a little tougher. This transistor sticks up, so brushing these things is a little more challenging. I usually like to have it as submerged as I can get it while I do this, but this one's coming out okay. You can see even after just maybe a minute or so, the flux is mostly dissolved already. The brush just helps knock more of this stuff loose, which is kind of what you need. It'll just sort of sit there, and you can let it sit for a couple of hours, and it'll just sort of sit there in its partially dissolved state. The brush is immensely helpful. You can use a toothbrush too, if you have an old toothbrush. Of course, one that you will not be brushing your teeth with. Maybe the floor tiles or something, but anyway. So you can see at this point, this flux is mostly gone off of this board. Some people will tell you to wear rubber gloves and this, that, and the other, and you probably should. I probably should. But I'm also just a hobbyist. This isn't my full-time job. I don't do this 8 hours a day, 5, 6, 7 days a week. So I am a little more laxed about the chemistry. So this board is mostly clean. Let's look at the top side. The nice thing about this is just I believe just a linear regulator, so you don't have to worry about digital signals. And power these on. If we see an LED light up, we'll be happy. The other thing I might suggest is maybe not putting this heatsink on until after you clean it. The heat sinks were new. I was excited. I put them on. So yeah, so this board looks pretty snazzy now. Flux is gone. So let's rinse these two before they get any buildup. In a factory, I'm told they use deionized water, which I guess is somehow safer. I'm not super familiar with chemistry, but I know enough to cause enough problems for myself. So here we go. This is Boldport whiteboard on a white board, and it looks really spiffy. So of course you ask again, does it work? Well, I've prepared the ultimate breadboard with an LED on it. The way I've got it wired, this is an RGB LED. If it powers on, we will get a green light from it. So I need to plug these in where the headers are going to land. And then also, these boards need to be separated. And I don't have a tool here. And I shouldn't be doing this with my fingers, but I believe if I twist this a little bit, these will snap for me. There we go. Whoops. How not to treat your really fancy Boldport kits. That SAR works very hard to design. Okay, that's out of there. So you can see this is designed so that this will go around the breadboard. I've got the little wires on it. I'm not going to bend them right now. I just want to see it in action. Let's blast it with some canned air real quick just to get any residual liquid off of here. Switch cans. So now if we plug this onto the breadboard, you see the pins line up just so. There we go. So we've got ground and then our positive supply. 9-volt power adapter. Voila! It works. If I was feeling ambitious, I would get the voltmeter and measure what we're getting, but I'm not. However, we have a variable resistor. It should adjust the voltage so you can see as I turn this, the LED dims, which is exactly what we expect. So I'm happy with that. So, I've got a couple more of these. I won't bore you watching all this stuff, but you get the general idea of how we can clean these things in fact, without damaging them. Even for something more complex that has a microprocessor on it with a whole bunch of LEDs and LED drivers and so on and so forth. This stuff is tough. Like I said before, it's largely just plastic and metal. So if you get it a little wet, you're not going to kill it. Just make sure you dry it right away. Don't leave it sitting out. Don't leave it in an oven or something silly where the water is going to evaporate and react. And more importantly, leave residue too. You get residues under these chips and around the connectors and various parts. That's when the damage occurs. Of course, it's not going to work if you run it underwater. Water does conduct, but don't be afraid to wash these things and make them look good. You worked hard. You want a good result to show to your friends so that you can say, hey, look how awesome this is, and people look at it and they go, wow, it looks like it came out of a factory. Yeah, if you get it nice and clean, it does look really great. Anyway, that's all for now. I hope you enjoyed. I hope that you have a better understanding of how you can remove flux from your own boards and projects so that you can have things looking just as snazzy as all these other kits. Thanks for watching.